Okay guys, this is a video on 3.7, which was systems. For linear and quadratic, the number of solutions that it could be, you could have one solution where you have a line intersecting a quadratic and hitting at just one point. You could have one. You could have two when you have a quadratic and the line going through. That's two solutions. And then you could also have no solutions where you have a linear and your quadratic could be above or below and there's no solution. Zero, no solutions. Okay, so the first method we're going to use is graphing. The bottom one is a linear. So y-intercept is -1 and the slope is -2. So I get some points. We have a line. Then the other one is a quadratic. It's in standard form, so I'm going to use my axis of symmetry. So that's -b over 2a. So my x is going to be 1. I'm going to substitute that back in. 1 minus 2 minus 1. That is going to be -2. So my vertex for my quadratic is 1, -2. My y-intercept is -1. Then I'm going to reflect it. My quadratic is this. My point of intersection would be 0, -1. Okay, the next one, these both are quadratics. My first one is, I'm going to go ahead and put my table because I will be using transformations. Guys, hopefully by now you can use transformations pretty good. So my vertex here is going to be 1, 1. I'm going to go over 2 and up 4. And then I'm going to go the same way. I'm going to go left 1, over 1, and reflect. Oops, this point should be right here. This is my first quadratic. My second quadratic, the vertex is 1, 1. So you have your point of intersection. This would be multiply the y by -2, so it's going to reflect. That's -8, left 2, and down 8, left 1 and down 2, reflect. So my point of intersection for these two quadratics will be their vertices, their vertex, which would be 1, 1. That's using graphing. Okay, now we're going to do algebraically, which means I'm going to either do substitution or elimination. So for this first problem, I'm going to solve for y for both of them. So on the second one, y equals x squared, -x squared minus 2x. And the first one, it is going to be y equals 2x squared minus 5x plus 2. So I'm going to take these two equations, I'm going to set them equal to each other. 2x squared minus 5x plus 2, and that's equal to -x squared minus 2x. So this is going to be a quadratic, though I need to bring everything to one side. 3x squared minus 3x plus 2, and I'm going to factor. See, make sure I did that right. 3x plus 2. Okay, so this is going to be, let's see if this is going to have a solution. I'm going to check my discriminant. to see if there's gonna be a solution, because if the discriminant is negative, that gives me an imaginary number. So that would be b squared minus 4ac, and that is going to give me a negative number. So this is going to be no solution. You can't have a negative under the radical. That would give us a root, but it would be an imaginary root. Okay, so the next one, hang on just a minute. All right, so the work has already been done for us. They have solved for y. So all we're going to do is set them equal to each other. So that would be negative x squared plus 4 equals 4x plus 8. I want my x squared to be positive. So I'm going to move x squared plus 4x plus 4 equals 0. And then I am going to factor. So this would be x plus 2, x plus 2. So we can see that this is going to have one solution. And the x value is negative 2. Then I'm going to plug it back in to this equation right here. So that would be negative 8 plus 8. My y is going to be 0. So my solution would be this, or my point is negative 2, 0. Okay, the next one, I am going to solve for y in the first equation. X plus 4 equals y. I'm going to set them equal to each other because they're both equal to y. Move it to the x squared side, keep the x squared positive, and I'm going to get x squared minus 5 equals 0. I can use square root method. X squared equals 5, x equals positive negative root 5. So I have 2 points of intersection. I have positive root 5, and I have negative root 5. I'm going to plug it back in to this equation. So when x is root 5, my y value is 4 plus root 5. And when x is negative 5, my y value is going to be 4 minus root 5. And those are my 2 points of intersection. Oops, not that way though. It's going to go this way, up and down. X and y. X and y. The next one, they've already been set equal to y. 3x squared minus 4x minus 1 equals 2x squared minus x plus 9. I'm going to move the x squared over, the x, and the 9. I'm going to factor. So x is going to be 5. X is going to be negative 2. I'm going to plug it into either of the 2 equations. It doesn't matter. So if I plug it into the bottom, 2 times 25 minus x plus 9. So that's 50 plus 4. Y is equal to 54 when x is 5. When x is negative 2, so that's 2 times 4 minus negative 2 plus 9, so that's 11 plus 8, y is equal to 19. Those are my 2 values there. Okay, on this one, solve for y. Top one, 2x squared plus 4x plus 2 equals y. The bottom y equals 2 minus x squared. So I'm going to substitute in. So this would be 2x squared plus 4x plus 2 equals 2 minus x squared. This is 3x squared plus 4x equals 0. Factor x out, x. This would be 3x plus 4. X is equal to 0, and x is equal to negative 4/3. I'm going to plug it back into this one. So this would be when x is 0, y is 2, and then 2 minus 4/3 squared, 2 minus 16/9, and this would be 18/9 minus 16/9, which would give me y equals 2/9. So this is 1 point. This is the other point. Okay? All right, now we have this area of a triangle. We know the area of the triangle is 120. This is 120, and the perimeter is 46. So the area formula is length times width equals 120. Perimeter is 2 times length plus width, and that is equal to 46. I can simplify that. Length plus width equals 23. I'm going to take this length plus width, I'm going to put it over here, but I'm going to solve for a variable. If I solve for length, it doesn't matter which one you solve for. So I'm going to take that and put it over here. And this is going to become a quadratic. So this is 23w minus w squared equals 120. I'm going to bring everything over. I want my w squared to be positive, so I'm going to move it to the right. And I get this. And then I'm going to look for my factors. That would give me 120. That is 15 and 8. Oops, that's supposed to be 15. So my two W's would be 15 and 8. Just like the problems above, we have two solutions. So I plug in my W. So when the width is 15, my length is going to be 8. When the width is 8, that means your length is going to be 15. Those are your two possible measurements. And that is all for this lesson.